Good morning, it's Monday 27th of April and we're looking at the Foundation CorbettMaths 5-a-day for 4th of May. Hopefully those questions in front of you do look familiar. What I'm saying there is that the increased question can be done with a calculator. Everything else should really be attempted without a calculator. If you want to pause the video now, if you haven't had a chance to have a go at these questions, please do, because I'm about to go through the answers. So let's have a look at these questions then. So the first two I felt were very straightforward. If you've got 6 b's and you take 4 b's away, you'll have 2 b's left. This is the multiplication, so I'm going to multiply these bits first. So 2 times 3 is 6, and b times c we write as bc. And we try to keep that alphabetically ordered. So 2 quite straightforward questions to get started there. Let's look at our calculate question now. I'm going to use the Casio for this. And the first thing I would do is I would find 17% of 54. Now there are other ways of doing this. I'm just looking at this method this morning. So 17 shift to get percent. And if you're wondering how I did that, I press my shift key there and my open bracket key there to get 17% of 54. And 17% of 54 is £9.18. Now there are other ways of finding that 9.18. If you take the 54 and you divide that by 100, by dividing by 100 you'll find 1%. 1 out of 100 effectively. So 1% is 0.54. Now I need 17 of those, so if I times that by 17 I'll get the 9.18. So if you're using your iPhone or a Google based phone, that might be a better way of getting the 9.18. This is an increased question, so I now add those together and that gives me 63.18. As I say, there are a number of ways of doing that with 117%. If you know that method, stick with it using the multiplier, but because this is a foundation set of questions, I'm going to stick with that method if that's okay. Okay, so moving to the next question where we had to find the volume and then the total surface area for the cuboid. I've just quickly sketched a cuboid. I've put the 3 side lengths in, 3, 4 and 5, and the volume will be this cross-sectional area here multiplied by its length. So the formula I'm going to use, because you're going to see me using that quite a bit in today's video, is the cross-section area. So 3 by 4 would generate that area there, and then multiplied by its length here, 5. So I'm just going to find the area there first, which of course will be 12. 3 4s are 12, and then 12 times 5 gives you 60. 5 10s are 50, 2 5s are 10, giving me the 60, and that'll be centimetres cubed of course, because effectively that was 12 centimetres squared, and then I was multiplying it by another dimension there. So hopefully the volume is quite straightforward. For the total surface area, there are a number of ways of doing this. You could think of it in its net form and you'd see the 6 faces, or you can have a look at this way. It's called a listing method. So I'm going to work, I already know this area here, and that area there is 12 centimetres squared, and that was the 3 times the 4. If you think about this vertical dimension here, that's the 3, so I can just write that 3 centimetres there. 3 5s are 15, so that's that front face sorted there. And now to find the top, well, that's using the dimensions of this width here and this length here, so that's 5 by 4, and that's 20 centimetres squared there. So that's all 3 faces there. However, there is a side left and a side right. There's a front and a back. And of course there's a top and a bottom. And there are the 6 faces I was just alluding to a minute ago. So they generate 24, they generate 30, they generate 40, and a quick total of that, 4, 4, 7, 8, 9. So the total surface area is 94, watch the units here, centimetres squared. And it's centimetres squared because you're adding areas together. So that area is added to that area, which is added to that area to give that area. So there's the total surface area and the volume of that cuboid done. I said I would use this formula again, the cross-section area multiplied by the length. So let's write that out now, because I'm now going to find the volume of the triangular prism. So if I can work out this cross-sectional area here, then multiply by its length, meaning I don't need to use that 5, I will find its area. So what I'm saying is I'm going to multiply by its length there, but I need to find the cross-sectional area first. So this is a triangle, so of course it will be a half times the base times the height. So a half times the base of 3 times the perpendicular height of 4. I can do them in any order that I want, so I can half the 4 to get 2. 2 times 3 gives me 6 centimetres squared. 6 sixes are 36, and there is the volume. So finding the cross-section area first, then multiply by its length, just like we did here. Find the cross-section area first using the 3 and the 4 to find that rectangle's area, then multiply by its length. The last question on the CorbettMaths was laws of indices, and in the first law of indices we've got 10 C's multiplying together, and then we're going to divide by 5 C's multiplying together. So if I just show what we're talking about here, this is exactly what that question is talking about. There are 10 C's multiplying together here, and there are 5 C's multiplying together here, and we're asked to divide them. So that of course is the fraction division there. C goes into C once, 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 C goes into C once. So these 5 C's go into these 5 C's once, leaving you with one lot of 5 C's multiplying together. So you get a final answer of C to the power of 5. What we're doing here is the second law of indices. And the second law of indices says that if you've got the same base here, which we have, a base of C, and we're dividing with an A and a B, we get a final answer of A minus B, and 10 minus 5 does actually generate that 5 there. So there's the first one done. The second one's a little bit easier. There are 7 C's multiplying here together, and there are 3 C's multiplying here together. So when you bring them all together, all the C's end up multiplying together to give you 10 C's multiplying together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this of course uses the first law of indices, which says if you've got the same base again, you can add the indices together. So first law of indices, when you're multiplying, you can add the powers together if you've got the same base. So 7 plus 3 is 10. Second law of indices, if you're dividing with the same base, you subtract the division, the dividing index off the leading index there, or if you think about numerator and denominator positions for your fraction. And then we come to this question here, which actually uses the third law of indices, but again I just want to show you what's actually happening here. If we are cubing something, then we have 3 instances of it, and they're all multiplying together. That's exactly what a cube means. So I've got 8 C's multiplying here, with another 8 C's multiplying here, with another 8 C's multiplying here. If you add up now how many C's are multiplying together, just like I did here, you'll see that there are 24 C's multiplying together. 8 of them are here, then multiply to another 8 C's, multiply to another 8 C's, giving you the 24 C's. And this actually is the third law of indices, which states that if you raise a base to a power and then to a further power, you can indeed multiply the powers, and 8 times 3 of course gives you that 24. The last question was a little bit sneaky. It was the second law of indices, so it was the one that we looked at here where we've actually got a division. I wrote it out as a fraction, so we're going to subtract the dividing index. And let's have a little look at what happens here then. So I could write it out first of all if I want to. Can't always do that, as you'll see in a minute. But that C will divide into there once, that goes into that once, that goes into that once, that goes into that once, leaving you with one lot of those. And one lot of those is C squared, of course. Or thinking about the laws that I can use, the dividing index is subtracted off the numerator index effectively. And that gives me the same answer as well. Now, as always, I'm going to give you some questions to have a go at now. So I've done a version 2 for you. I've put 3 minutes on the clock. See how you get on. If you need more than 3 minutes, please press the pause key. And as you can see, I've said that the decrease question, where we're doing a percentage change, you can use a calculator. See you in 3 minutes. So remember, if you need more time, please press the pause on the video now. There's no need to go straight into the answers. 3 minutes isn't a very long time, to be honest, to go through those questions. And press pause now as I'm about to go through the answers. Okay, quite a sneaky question here. If I've got 12b squares and I take 4b squares away, I'll actually have 8b squares. So if I caught you out there, I do apologise, but I was trying to show you something that does come up on the exam quite often, actually, more often than you'd realise. And this question here, 7 8s are 56. There it is again. I think I've tried to get that into every single video I've done so far. C times c squared. Well, we're looking at laws of indices there, aren't we? So that's 56c to the power of 3, because effectively that is c to the power of 1. We're decreasing 68 by 13%. Well, hang on a minute. Let's find 13% of 68 first of all. You can divide that by 100 and times by 13 if you're using an iPhone. But I'm going to use the Casio shift to get the percentage key. So I've got 13%, times that by 68, and that gives me £8.84. This is a decrease this time, a decrease question, so I'm subtracting. It's a calculator question, so I'll just type that onto the calculator, and I get £59.16. Make sure that decimal point is clearly seen in the exam when you do these for real. Not a football, as my maths teacher used to say to me, but so you can clearly see it. So we're doing volume and total surface area of this cuboid. As you know, we're going to use cross-section area multiplied by length. We're going to find this cross-section area. 4 times 6 is 24, and then we're going to multiply by this length, which is 8. Now, without a calculator, I would do a bit of partitioning here. So I do 20 times 8 and 4 times 8. 2 8s are 16, so 28s will be 160 because of that power of 10, and 4 8s are 32. Add that back together, and I get the volume as 192 centimetres squared. So well done if you got that answer right. I'm just quickly checking that on the calculator. We all make mistakes, and I haven't for once, so that's quite nice. 192. Going back to the total surface area, so we know that this area here is 24 centimetres squared, and I've got a side left and a side right, so they'll add up to 48 centimetres squared. Then I've got this vertical here is 4, so I've got 4 8s are 32 centimetres squared for the front and the back, so I've got 32 plus 32, which will give me 64 centimetres squared. And then the top is using the bottom dimensions effectively, so I've got 6 8s, which are 48. So I've got a 48 and a 48, which gives me a 96. And if you're wondering why I did that so quickly, I thought about 50 plus 50 is 100, but I'm too short, so I'm 4 short. So now adding these numbers together, well, that's a nice number bond there. So there's 10, so there's 18 straight away. There's a nice number bond, there's another nice number bond, so 208. Again, I did say for you to do this on without a calculator, sorry. I'm just going to use my calculator to check my answer. 208 is the total surface area, and again centimetres squared. So using that sneaky listing method, there are many ways you can use a nets. I've even seen students find those 3 and times by 2. So if that's the way your teacher has taught you to do it, that is not a bad way at all. Find the total of those 3 and times by 2. We're doing the volume of the triangular prism now, so it's cross-sectional area times by length. So I need to find this area first, and then I'll multiply by 6, and I won't use the 7 at all. Okay, so let's find this area. Area is a half the base times the height. So the area is a half times the base of 4 times the height of 2.5. Now, halving that seems illogical, really. I think I'll go for this first. 4 lots of 2.5. And 4 lots of 2.5 will give me 10. 2.5, 2.5 is 5. Double that is 10. So the area is a half times 10. I could have halved that to get 2, and 2 2.5s would give 5, or indeed half a 10 gives 5 as well. So my cross-section area is 5 centimetres squared. Times that by the 6, and I get my volume is 30 centimetres squared. Again, I'm just going to very quickly check that on the calculator. I'm confident with this one, but we can all make mistakes. Yes, it's 30, that's good to check. And let's move on to the laws of indices. I'm just going to quickly drop the blind there. There's a lot of sunlight getting in today. I hope that's a little bit easier to see. I do apologise. That's much better, isn't it? So, second law of indices, which I hadn't drawn that, but never mind. Second law of indices, so it's 12 minus 7, which is 5. I could have drawn that out, of course. There's 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7. That goes into that once, 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 leaving me with 5 C's still multiplying together. So C to the power of 5, write it properly. There it is, C to the power of 5. This question here, we've got 8 C's multiplying together. And we're going to multiply by a further 3 C's. If you add them together, you get C to the power of 11. And again, that first law of indices, we're adding together there. Moving on to this one, the third law of indices. So we're raising to the power of 4, and then we're raising to the power of 5. So straight away, I'm hoping you know the answer is 20. But let's prove it again. Always nice to see this. So raising to the power of 5 means I have that number 5 times multiplying together, which effectively means, you don't have to do this in the exam, but it's a lovely little checking mechanism. That's what's going on. I've got those 4 C's multiplying to 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 those 4 C's, add all them together, and you will get C to the 20. On my final question, I threw in a curveball there with a negative. So if we show what the second law of indices says, that minus will turn that minus into a positive, and you will end up with C to the power of 10. So a rather nasty question there. Higher students know that if there's a negative there, they can actually move it to the numerator and it becomes a positive, and that's kind of the proof of what is happening there. So that you'll see if you do some higher maths. Thank you very much for today. Let's have a quick look at next Monday's work. So we'll be moving on to the 5th of May, the foundation work there, and maybe a couple of calculator questions there. Actually, we've got another plan view question there, and we're doing a reflection and a rotation, so that's quite nice. We'll be able to have a look at them. Might be difficult to reproduce them for an extra question, but I'll definitely be able to reproduce these for you. Thanks for tuning in. I hope you found that really useful. Stay safe, everybody, and I will see you in a week's time for May the 5th.